The National Electrical Code, or NEC, specifies color codes for electrical systems to ensure safety and prevent confusion. For a 120/240 volts delta system with a 208 volts high leg, the following color codes should be used. Firstly, phases should be black. Secondly, phase B should be red. Thirdly, phase C, which is the high leg, presents a unique situation. The neutral conductor is always white. The NEC designates orange as a phase color for 480 volts systems. Using orange for the high leg in a 120/240 volts system would create a conflict with the 480 volts color coding, potentially leading to dangerous mistakes. To avoid confusion and maintain NEC compliance, the recommended color coding for the high leg, phase C, in a 120/240 volts delta system is blue with orange tape. This clearly identifies the high leg wire while differentiating it from the standard 480 volts phase color, which is orange. The orange tape serves as a visual warning that this blue wire carries a higher voltage than the other phases. Some utility companies may have their own preferred color coding for the high leg. It's always advisable to contact the local utility for specific requirements before installing any electrical wiring to ensure compliance with their standards. Following the NEC guidelines and consulting with the local utility helps ensure a safe and properly identified electrical system. The NEC color coding is not just a suggestion, it's a safety standard designed to protect electricians and other personnel working on electrical systems. Deviating from these color codes can lead to misidentification of wires, increasing the risk of electrical shock, arc flash, and other hazards. Proper identification is crucial for troubleshooting, maintenance, and future modifications to the electrical system. When working on a 120/240 volts delta system with a 208 volts high leg, it's essential to double-check the voltage of each phase before making any connections. The higher leg has a voltage of 208 volts to ground, while the other two phases have a voltage of 120 volts to ground. This difference in voltage can be dangerous if not properly understood and respected. Using a multimeter to verify the voltage of each phase is a best practice that can prevent accidents. Always follow lockout-tagout procedures before working on any electrical equipment to ensure that the power is turned off and cannot be accidentally turned back on. Lockout-tagout involves disconnecting the power source, locking the disconnect switch in the off position, and attaching a tag that warns others not to turn the power back on. This helps to prevent accidental energization of the circuit while work is being performed. Regular inspections of electrical systems can help identify potential problems before they become hazards. Look for signs of damage, such as frayed wires, loose connections, and corroded components. Address any issues promptly to prevent further damage and ensure the safety of the system. Proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Make sure that all electrical equipment is properly grounded and that the grounding system is properly maintained. Education and training are key to preventing electrical accidents. Ensure that all personnel working on electrical systems are properly trained and understand the hazards involved. Provide regular refresher training to keep their knowledge and skills up to date. In addition to following the NEC guidelines and consulting with the local utility, it's also important to follow any other applicable codes and standards. These may include state and local electrical codes, as well as industry standards such as those developed by the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE. Staying up to date on the latest codes and standards can help ensure that electrical systems are installed and maintained safely and properly. The NEC is updated every 3 years, so it's important to stay current on the latest changes. These changes may include new requirements for color coding, grounding, overcurrent protection, and other aspects of electrical safety. Subscribing to a reputable electrical industry publication or attending a continuing education course can help you stay informed about the latest changes to the NEC. When working on electrical systems, always use the proper personal protective equipment, or PPE. This may include safety glasses, gloves, and arc-rated clothing. The type of PPE required will depend on the specific hazards involved. Consult with a qualified safety professional to determine the appropriate PPE for each task. Never work on electrical systems when you are tired, distracted, or under the influence of drugs or alcohol. These factors can impair your judgment and increase the risk of accidents. Get plenty of rest, avoid distractions, and stay sober when working on electrical systems. If you are not comfortable working on an electrical system, don't hesitate to call a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and properly. Attempting to do electrical work yourself without the proper training can be dangerous and may violate local codes. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. Electrical safety is everyone's responsibility. By following the NEC guidelines, consulting with the local utility, and taking other precautions, you can help prevent electrical accidents and ensure the safety of yourself and others. Always remember to treat electricity with respect and to follow all safety procedures. The 120/240 volts delta system with a 208 volts high leg is commonly used in light industrial and commercial applications. It's important to understand the unique characteristics of the system in order to work on it safely and effectively. The high leg, also known as the Stinger leg or wild leg, is the phase that has a voltage of 208 volts to ground. The other two phases have a voltage of 120 volts to ground. This difference in voltage can be used to power both 120 volts and 240 volts loads. For example, 120 volts lighting and receptacles can be connected to the 120 volts phases, while 240 volts equipment such as air conditioners and water heaters can be connected between two of the phases. The high leg should never be used to power 120 volts loads. Connecting a 120 volts load to the high leg will result in overvoltage and damage to the equipment. The high leg is typically used to power three-phase equipment, such as motors and pumps. Three-phase equipment requires a balanced voltage supply, and the high leg can provide this. When working on a 120/240 volts delta system with a 208 volts high leg, it's important to be aware of the potential for harmonics. Harmonics are distortions in the voltage and current waveforms that can be caused by nonlinear loads such as electronic equipment. Harmonics can cause a variety of problems, including overheating of equipment, nuisance tripping of circuit breakers, and interference with communication systems. To mitigate the effects of harmonics, it's important to use harmonic filters and other mitigation techniques. Harmonic filters are devices that are designed to reduce the level of harmonics in the electrical system. Other mitigation techniques include using shielded cables and properly grounding the electrical system. The NEC provides guidelines for the installation of harmonic filters and other mitigation techniques. These guidelines should be followed to ensure that the electrical system is properly protected from the effects of harmonics. In addition to the color coding requirements, the NEC also specifies requirements for the identification of conductors. Conductors must be identified by their color or by other means, such as tagging or marking. The identification must be durable and easily readable. The identification must also be consistent throughout the electrical system. This helps to ensure that conductors can be easily identified and that mistakes are avoided. The NEC also specifies requirements for the spacing of conductors. Conductors must be spaced sufficiently to prevent arcing and short circuits. The spacing requirements vary depending on the voltage of the conductors and the type of installation. The NEC also specifies requirements for the protection of conductors. Conductors must be protected from physical damage such as abrasion and impact. Conductors must also be protected from overcurrent such as short circuits and overloads. Overcurrent protection is typically provided by circuit breakers or fuses. The NEC provides guidelines for the selection and installation of overcurrent protection devices. These guidelines should be followed to ensure that the electrical system is properly protected from overcurrent. The NEC also specifies requirements for the grounding of electrical systems. Grounding is the connection of the electrical system to the earth. Grounding helps to protect people from electrical shock and also helps to prevent damage to equipment. The NEC provides guidelines for the grounding of electrical systems. These guidelines should be followed to ensure that the electrical system is properly grounded. The NEC also specifies requirements for the wiring methods used in electrical systems. Wiring methods include conduit cable and open wiring. The NEC provides guidelines for the selection and installation of wiring methods. These guidelines should be followed to ensure that the wiring system is properly installed. The NEC also specifies requirements for the installation of electrical equipment. Electrical equipment includes switchboards, panel boards, transformers, and motors. The NEC provides guidelines for the installation of electrical equipment. These guidelines should be followed to ensure that the electrical equipment is properly installed. The NEC also specifies requirements for the inspection and testing of electrical systems. Electrical systems should be inspected and tested to ensure that they are installed properly and that they are safe to operate. The NEC provides guidelines for the inspection and testing of electrical systems. These guidelines should be followed to ensure that the electrical system is properly inspected and tested. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. Electrical safety is everyone's responsibility. By following the NEC guidelines, consulting with the local utility, and taking other precautions, you can help prevent electrical accidents and ensure the safety of yourself and others.